Okay, so welcome back for all you future chemistry uh, scientists. Make sure that you go ahead and you uh, what should we do to the like button today? I don't know. I guess you hit the like button. I still like the seesaw one. What else could you do? Oh, take the like button. Take the like. Take the like button to a. Uh, they have these where they breed fish, and walk with the like button, looking at all the fish, all the different types of fish that are in the pools as you're walking past, and then push the like button so that they fall in and then run away. Um, yeah, so do that, and then make sure you subscribe, leave comments down to let me know if you did that to the like button. And oh, one other thing that I would like to tell you, remember to make waves. Be a moon and make waves. So let's go ahead, and we are going, this is the balancing redox in an acidic, and this is the example. So this would come after the PowerPoint. So let's go ahead and present and get through this one. I am here on a day when there is no school. I actually did not realize that we didn't have school today, and I just showed up, and I showed up to school, and we don't have school today. So yes, just make sure that you always know that when school is or when school is not in session. Don't be like me and show up and then realize that you're not supposed to be here. So, okay, it is the day after conferences, and I am here at school when there's nobody else in the building. Go figure. Okay, so this is balancing an acidic solution. How will you know if it's in an acidic solution? It has to be told to you. So if you do not know, you have to read the directions, and it should say that it's balancing in an acidic solution. And then once you know that you're balancing in an acidic solution, then we will go with the guidelines for balancing an acidic. Now, if you have those guidelines memorized or internalized and you just know them, then it's going to become something that makes it a lot easier. So here we go. So our first step, if we look at this, and you'll see that I am not going to write out every step. This is a reaction we are given. We're trying to balance this. So separate it into half reactions. In order to do that, I am going to just take, it doesn't matter which one, I'll take this one. So we are going to, our half reactions, we have PB, OH, 4, 2 negative, and that goes to PB, O2. And then on the other half reaction, we have ClO negative going to Cl negative. So there's our two half reactions. First thing is balance everything that is not oxygen or hydrogen. So the lead is balanced and the chlorine is balanced. So now I'm on to the next one. The next one is balance all the oxygens, adding water. So it looks like this. I have 2 oxygens here. And over here, I have 4 oxygens, so I have to add 4, let's see, 8, or not 4. Ooh, what am I doing? I don't want to add 4. I want to add 2 H2Os. For this one, I have this, and I have 1 oxygen, so I need to add 1 water on this side. Now, this is kind of giving me a little bit of worry because I've added the waters to both sides. Let's see how it plays out. We just have to make sure that the electrons are going to be to opposite sides. So after you balance out your oxygens, now you're going to balance out your hydrogens. Well, here I have 2 hydrogens there, so I need to add 2 hydrogen ions. And then over here, I look at this and I have 4 hydrogens here. I have 4 hydrogens there. It's already balanced. I don't have to worry about that. So it was worrisome at some point. Let's just see if I add the electrons to the same sides or not. So in this side, I have a -2. This is 0. This is 0. So I need to add 2 electrons to this side. Now on this side, I'm going to just draw a line there. For this one, I see that this is a -1. This is 0. So a -1 charge on that side. This is -1. This is a +2. So I have a +2 minus 1 gives me a +1. I got to get a +1 down to a -1. In order to do that, I need to add 2 electrons to this side. Well, now that I've added those electrons, it's nice because those electrons are actually the same. So my next step would be balance out the electrons. They are balanced. Are those electrons added to opposite sides? One is added to the product side. One is added to the reactant side. Yes, they are. So I am good with that. Now, since they're balanced, I don't have to worry about that. I am going to write all of my reactants on one side, all of my products on one side. So I'm going to write PbOH 4 2 minus plus, over here I got 2 electrons. I'm just going to add them here, plus 2 hydrogen ions here, plus ClO negative. And then on the product side, I am going to put PbO2 plus, Cl negative plus 2 H2O plus 2 electrons plus H2O. Now this one's kind of unique because I have the waters on both sides. So I can look at this and I can cancel out my electrons. Boom, boom, those are done. I need to combine these. So I need that to be 3 H2Os. And then the hydrogen ions, I can't cancel out the hydrogen ions or the water. So my final reaction is going to be ClO negative. That's going to be AQ plus PbOH 4 2 negative plus 2 hydrogen ions. This is AQ and this is AQ. How do I know those are all AQ? I know those are all AQ because they all have charges, so they're ions. Over here, PbO2, and that's going to be a solid plus Cl negative, and that's AQ plus 3 H2O. That would be a liquid. And then I can look and I can make sure that they are balanced. If I do, I got 2 hydrogens, 4 hydrogens, so that's 6. I've got 6 hydrogens. I got 1 lead. I've got 4 oxygens, 5 oxygens on one side. I got 2 and 3 more, that's 5. And then I got Cl. It is balanced. The only other thing that you might have to do is you might have to say what's being oxidized and reduced. In order to do that, I would just write all of my elements. Oxygen, that's going to be a -2. Cl, if that's a -2, that has to be a +1 on this side. Lead, this is -4. This is going to be a +2. And then on this side, we are going to have Pb is going to be a +4. Cl is a -1. H is a +1. Oxygen is a -2. So I look at that and I can see, well, look what has changed. My lead has changed and my chlorine has changed. So what is being oxidized? Oxidized is losing electrons. It goes up in charge. My lead is oxidized. So Pb is oxidized. That means it's the reducing agent. And then Cl is reduced. That means it's the oxidizing agent. Because Cl goes from +1, it gains electrons, it becomes more negative. And that's it. So if you are doing these, make sure you're working on those worksheets. Hopefully it's making sense. If you are not getting it, then come in for help. And let's make sure that you're able to balance an acidic. If you can balance regular, if you can balance an acidic, now you just need to make sure you can balance in a basic. And we will address that next time.